So our next topic in transformation geometry is rotations. So we have done translations before. We have just moved things around, right? We had, for example, some kind of shape, and well, that was the same shape just being moved around, just being moved as if you're dragging things around, sliding them on the paper. Now we're going to rotate things. So I have something here, and now it's going to rotate. So let's define a few things. Let's say that I have a point P, X, Y, all right, and we'll have some point which won't move. The only point in this case that won't move, let's say that it's the origin here, 0, 0. So I could have, for example, this point rotating in a certain angle. So if I measure this angle here, it's positive counterclockwise. So this would be my positive angle, theta, that rotates my point Pxy into P prime X prime Y prime. So here it's important to notice that our vector POP prime is positive, right, if our angle is counterclockwise, and it would be less than 0 if it's clockwise. So basically, what does that mean? If I'm rotating in that direction that I've shown you here, so I had my point P and I've got my point P prime, so it has rotated counterclockwise, this is positive, this angle would be positive. If I was rotating on the opposite direction, right, towards the clockwise direction, then it would be a negative angle. For the scope of this chapter, we're going to focus on rotations of 90 degrees, 180 degrees, right? So very simple rotations, basically a quarter of a rotation or half of a full rotation. So let's try with a very simple example now. So we've got this image. Find this image of the point 3, 1 under rotation about O. So origin 0, 0. So find the image which is 90 degrees anti-clockwise, and then 90 degrees clockwise and 180 degrees. So first of all, let's find where this point lies. So it's 3, 1. So x is 3 and y is 1. So x is 3 and y is 1. So my point, first of all, my point, let's say point P is here, 3 and 1. Now on letter A, our point is going to be rotated towards our origin, an angle of 90 degrees anti-clockwise. Now if you rotate this point 90 degrees anti-clockwise, so if you notice, look, you could visualize a triangle, right? Because the point would be here. So if you can see that, that's fine. Now if you cannot, take a look. We have just like a triangle. So if we rotate, let's say this line 90 degrees, right? So if we rotate all of this 90 degrees, we would have exactly this triangle here, right? But the whole point is, this point is now going to come here, right? So it's new position. So if this is point P, this could be, let's say, P prime, I don't know, 1, right, because we're going to have different ones. So this would be x equals, take away 1, and y equals 3. Now if we rotate 90 degrees clockwise, it's the same thing, but now it's going in the opposite direction. So if you do the same thing, right, with this triangle here, oops, you would have that this point is now here, so P prime, let's say P2 prime, would now be coordinates x equals positive 1 and y equals negative 3. And if it's rotated 180 degrees, you could just continue this line. You would observe this. It's the same gradient, right? But, well, it's the same thing if you rotate, keep doing this. You could also draw this triangle here, so it works regardless of which angle you're looking for. So you would have, let's say, T prime, and then coordinates would be negative 3 and negative 1. If it was in paper, it would be easier, but we could actually try to get a actual circle, right? Using a protractor, we should be able on paper to do it a bit better than what I was able to do here with the digital tablet. Alright, but if you notice, any point which would lie in, if this was a circle, right, any point which lies inside of that circle would be a point which would be a rotation of that original point about 0, 0. The only thing is that we're only going to deal with rotations of 90 degrees or 180 degrees. Right? And if we think about this rotation here, when we say 90 degrees clockwise, that's the same thing as 270 degrees anti-clockwise, right? Same thing, right? If you go 90 degrees to this side or 207 to this side, it's the same thing. Well, also, if you notice, if you have a point, let's say x and y, and let's say that you have a rotation of 90 degrees anti-clockwise, so you would have this turning into our P1 prime, and, well, it's actually take away y, x. If we're doing 90 degrees clockwise, our P2 prime, so this is the same thing as 270 degrees anti-clockwise, so this is 270 degrees positive. This would be negative 90 degrees according to our frame of reference. Well, anyway, our P2 prime here would be y and take away x. So it's the same thing, but signs flipped. And our P3 prime, which is the same thing as our point, but signs flipped. So negative x and negative y. Okay, so let's take a look at this different problem now. So we've got a triangle ABC with vertices A, negative 1 and 2, B, negative 1 and 5, and C, negative 3 and 5. So first let's draw this triangle. So vertices A, B, and C. So A, negative 1 and 2. So this is A. Now B, negative 1 and 5. B. And C, negative 3 and 5. So this is our triangle ABC. It's a right triangle. Right, and there we go, we have to find it. Now, it's rotated clockwise through 90 degrees, about negative 2 and 0. So this is our pivot point. This is the point towards everything at which, right, things are going to rotate towards. So now, and it's clockwise 90 degrees, so it's going that way. It's clockwise, so it would be the same thing as negative 90 degrees. If they didn't say anything about clockwise, negative 90 degrees would also mean it's going on this direction, and in this case clockwise. So draw the image of the triangle ABC, and label it A prime, B prime, and C prime. So what we're going to do here is quite similar to what we've done before in the previous example. So this is actually the vector which is pointing towards our point, which is going to be rotated, right? So we are rotating 90 degrees. So this is going to become this, right? If we rotate this point clockwise through this point, right, what's going to happen? It's going to go that way. And then since this is 1 to the right and 2 up, this is now going to be 1 down and 2 forward. So this is our new point A prime. Now this line was vertical. Now it should be horizontal. The length was 3 units up. Now it's going to be 3 units right. This line BC was going to the left, and now it's going up. And we can draw the last line of our triangle here. So this is A prime, this is our new B prime, and this is our new C prime. So labeling those, we are going to have A, which was -1 and 2, being transformed into A prime, which is now 0 and -1. B, -1 and 5, is being transformed into B prime, which now is 3 and -1. C was -3 and 5, and now it's being transformed, so it's being rotated, and now the coordinates are 3 and 1. So for our final rotation example, we're going to have an equation of a line. So we have this line, which equation is 2x minus 3y equals take away 6. And it's undergoing a clockwise rotation about its origin point, 0, 0, through 90 degrees. Well, first thing, let's try to understand how this line is. So what happens, for example, when x is 0, right? So when x is 0, we'll have a -3y equals -6, so y is 2, right? Now, what happens when y is 0? So basically I'm trying to find the y-intercept and the x-intercept, or the roots, right? So when y is 0, this is going to vanish, so 2x equals -6, therefore x is take away 3. So using those 2 points, look, from this I can get points, let's call it, I don't know, I won't name them, but 0, 2, and from this one, -3 and 0. So I could actually plot those points here. Okay, let's name them. So P1, P2. So I've got P1, 0, x equals 0, y equals 2. This is my P1. And P2 is -3 and 0. This is P2. And, well, the line is the only line that I could describe which goes through those points. So that's our original line. And that's the line which we are actually rotating. This is, so if I had to write the equation 2x minus 3y equals take away 6, this is the equation that we're talking about. Now, if we're looking for a clockwise rotation against this point, Now, for example, point P1, if it was here, and now it's going to suffer a clockwise rotation, right? So clockwise. So clockwise, it's going this way. So if it was 2, height was 2, x was 0, and y is 2, now it's going to be here. If you rotate this 90 degrees, it's going to lie here. So it was y equals 2 and x is 0, x was 0, and now y is 0 and x is 2. So we know that this is our P1 prime. Good. Now, for the next point, this was our P2, which lied on this point 3. If it has been rotated 90 degrees clockwise, so it would go this way, and it would now lie here. So this point would be our P2 prime. And we should be able now to draw a line connecting those 2 points. So let's try. Oops. Nope. So approximately that line, right? That would be our line, our new line now, going through those 2 points. Right? Now, how can we find the equation of that line? Right? So we know our 2 points. We know point P1 prime. So P1 prime, x is 2 and y is 0. And we know P2 prime, which x is 0 and y is 3. So we're going to try to arrive at some equation. Y equals ax plus b, and we know 2 points. So if I use the first point, x is 2 and y is 0, so if I use the first point, I will get y equals 0 and x is 2, 2a plus b. If I use the second equation and I substitute y equals 3 and x equals 0, I will simply get b equals 3. So if b equals 3, I need 3 plus 2a to be 0. Therefore, a will have to be negative 3 halves. If you notice, if we multiply this by 2, we'll have negative 3. Negative 3 plus 3 is 0. So using those 2 constants, we can rewrite our line equation, and we would have then negative 3 halves of x plus 3.